Faculty of Informatics, Masaryk University in Brno, Czech Republic. Today I will present our accepted paper entitled Blockchain-Based Real-Time Healthcare Emergency. This work is done in collaboration with my colleagues Thomas Lavin and Tomasz Pittner. During this presentation, I will follow this plan. I will start with a general introduction about blockchain technologies and the healthcare application. That means the integration of blockchain in the healthcare application. Then I will present the problematics and the motivation of this work. And then I will describe our contribution. And I will finish by a conclusion and mention some future works. The general introduction is it will be about the blockchain technology, because the basic idea of this paper is the integration of the blockchain techniques in the healthcare application. It means and exactly in the remote access of healthcare system in the emergency cases. As you know, blockchain technology was seen in October 2008, and it appears with the Bitcoin and cryptocurrency. But now many other domains start using the blockchain. One of those domains are the banks, the insurance, the health, and many others: industrial domain, financials, public sector, insurance, retail, manufacturing. And our contribution is based in proposing a real-time healthcare system based on the blockchain technology that supports the life cycle of patient in the healthcare system. And what we did exactly, we improved the quality of the healthcare system by ensuring a consensus around tests and information about the patient, and by centralizing the prescription system. We collect the patient health data by integrating medical IoT devices. It means we connect many sensors and the body of the patient, and those sensors, they will send the information or the health data about the patient like remotely. By using the blockchain platform, of course, to the doctors and to the nurses and to all the health staff. And we provided data access control to restrict the access to the guaranteed persons. The general architecture of the Hyperledger fabric is described in this figure. Here, for example, we have two organizations, and they are connected by using the blockchain network, and inside the blockchain network we have connection between the organizations by using channel. It could be one or more channels. For example, here we have two, and inside each channel there is a smart contract. The smart contract, the channel with the smart contract composes the chain code. It means here we have two chain codes that are able to connect the two organizations. Inside each chain code there is a channel. Inside the channel there we have smart contract. Let's see a real example in our solution. The organizations could be hospital, university, hospital, and smart ambulance. The chain code could be, or the channels exactly, could be prescriptions and data test or data test for diagnostics. And for example, in here the hospital, they can write, it means the doctor is inside this hospital, they can write some prescriptions. The smart ambulance, they can share information about the patient. Let's see the exact solutions of our paper is about using how many? Five organizations, which are the hospital, university hospital, doctors, pharmacists, and smart ambulances. Here, what we did, we divide the system in some rules or some restrictions of using. For example, who can write, who can add and see. For example, here the doctors are able to write the prescriptions, but the pharmacists, they can validate these prescriptions only when they receive them from doctors. The smart ambulance, they can add some data or some tests about the patient. The patient himself can see the prescriptions and the historic. Of course, doctors can see historic, smart ambulance can see historic, and based on the historic which is distributed in the blockchain platform, it helps the doctors to decide which kind of prescriptions they can give to the patient, and also based on the historic, also the nurses or the people, the staff working in the smart ambulance, they can also know which kind of health issues could happen to this patient. And after that, what we added exactly, we think about how to make the system more automatic, or added some automation service. We add some kind of intelligent agent. And for example, here we implement the intelligent agent in the doctors' organizations. As for example, doctors, they are very busy, they couldn't verify, and for the endorsement or for the endorsing each transactions, they will use some intelligent agent which are able, for example, to search the information in the historic, which also can notify the doctors about any new update. And yeah, they can update the request. They can also wait for requests. They will be in touch or in connection with many database, which they can, for example, create of historic check it. They can see, they can add some historic channel, and based in the output of the intelligent agent, the doctors can decide, but he will decide by himself, of course. Just the intelligent agent will help the doctors to make many activities. And the class model, what we did exactly, we have the class model for the chain code in the historic channel. We have another class model for the chain code prescription channel. Of course, we can give for each historic class model the work ID or the worker ID, the organization ID, the hospital service ID, the patient ID, the date of the transaction, the details, and also for the prescription model, of course, we have to give ID to the prescription. As a doctor who write this prescription, the doctor ID, the hospital ID, the hospital service ID, the patient ID, the date, the drugs list, and the details. And for the rights for each organization and user, here who can read, who can, for example, for the chain code, create prescription, the doctor can read and write, but nurses, they just can read the prescription. For example, for the chain code, validate prescription, just for validation, doctors can validate, the doctors can read, and nurses can read. Yeah, for historic, everyone, I think, can read and write. Not everyone, of course. Patient, they are not able to see. They are able only to see the historic, but they couldn't write. But nurses, they can also add information or get about some historic issues. For the implementation, we use the Hyperledger Fabric, and we create our network with 6 organizations that were listed before, and 3 channels. The 3 channels are the prescription channel, the data channel, and the historic channel. And here is the environment. We use it like Ubuntu, a number of processors. Here we describe it we used also hyperledger caliper. All details of the test environment are described here. For the results, we test our network in terms of send rate and average latency and the throughput. It means here we test each function for create prescription, also for the transactions which are success transaction and the failed transaction, for create prescription, for query prescription, for validate prescription, for create tests, for query tests, and for add moments, query historic and add requests, and query requests, and query all request, and update request. And all results here they showed, for example, for the average latency, that means the time is still okay, like 3 or 4 seconds for transaction operations, it's okay. The also send rate, that means the transaction per second, it's also okay. The number of successful transactions is also okay. Most of them here we have 500. We used 500 transactions, and all of them are success. Maybe one times could be because of the some noise or some problems in the routing path. And the conclusion, like in this paper, we proposed a real-time healthcare system. This is based on new blockchain platform. This platform has the potential to improve hospitals' ability to control patient, and also to facilitate the implementation and operation of a distributed ledger solution based on Hyperledger Fabric, and with the connect permission, the medical staff, patient, ambulance staff, and medical IoT devices can see the blockchain content. For future direction, we first plan to improve our model to make it more suitable in the real life by defining more organizations, adding the healthcare authority or also the insurance companies. We plan to add a payment channel to centralize payment. There is problem of the anti-collision system also is one of the most important issues. We plan to develop an anti-collision protocol to solve this problem.